Thanks, Craig. That was terrific. So we've got questions that have come from our audience today, and they're a little bit non sequitur, so I'm going to be jumping around a little bit. But the first question I think people have is, why the move from wood to steel? This would be one of my first questions as well.
Yeah. Well, there were a number of reasons, and we experienced some things in the Phoenix plant that were troubling. We had a lot of waste, we had a lot of cullage, and we started experimenting with cold form steel that comes in a roll. And there's frankly almost zero waste, right? You're rolling every stud exactly the size you need it, and it's perfect. So the dimensional quality of it, there's no shrinkage in the field that we also had challenges with, accuracy, and honestly, our customers want it. So when we started offering it up to customers, there wasn't a customer out there who said they wouldn't rather have cold form steel than wood for stick frame. This has nothing to do with the mass timber buildings at all, but when it comes to frame buildings, it was desirable.
Just a follow-up question on that. Did the quality of lumber? I toured your Phoenix plant about a year and a half ago, and I recall I asked the plant manager at that time what he thought of the quality of lumber he was receiving, and he wasn't too pleased with it. And he told me at that point that you were actually doing some tests at a building nearby with cold form steel at that time. Did the quality of lumber have anything to do with this decision?
Maybe a little, but not all. I mean,
yeah.
Even if the lumber was good, I think that we may have ended up with jumping to the same conclusion.
Okay, sure.
Yeah.
So what are the barriers you see for sort of faster growth of offsite construction? What kind of barriers do you see out there that concern you the most?
Well, yeah, I think it's building the capacity to keep the plant in operation. I mean, the only way to drive the cost down is to have that plant operating full tilt and have people fully employed. Running 2 or 3 shifts is how you drive the cost of the product down, and you have to have the demand. So it's kind of the cart before the horse syndrome here, and I think that's one of the things that has held this industry back. There have been plenty of people who have, tried to make an entry into this, but you're waiting for the phone to ring before you start the next project.
Right.
And so getting commitments, solid commitments from big developers who can say, I'm going to give you 5,000 units a year to produce.
Right.
Then you can make that commitment to build another factory,
sure,
hire another 100 people or 150 people to put in that factory. It's a massive undertaking in CapEx and OpEx to do that.
Sure. Another question off base here, but most of what you're doing seems to be in the panelized realm. Why not modular? Are you thinking about doing modular in the future? When I mean modular, I mean full volumetric.
Full volumetric.
Yeah.
Yeah, we looked at that pretty hard, and it was an easy decision for us because of the fact that we knew right away that we wanted to go nationwide or all of North America. And this is a big, big country geographically. This is, I think there's some great companies in the UK, for example, with Schmon Homes, are very successful at doing volumetric. But logistics costs can just kill you. You can lose all of your savings in trucking the product. And it requires a lot more space in the factory. So we made that decision pretty early. There are advantages in both ways. I think in the hospitality world, that's where that's headed. And I think there would be a lot of room for people to do very well with volumetric for specific market sectors. But in the market sectors that we want to take on, it just wasn't a good fit.
And what are those market sectors specifically?
Yeah, multifamily, of course, that's our most mature. Student housing is right there for sure. And then commercial office, light commercial, and there's a lot of talk right now in the company of moving into single family as well. Really?
Interesting. And how would you approach single family?
The same way that we do multifamily. So it's essentially using the same materials, same kit of parts. I mean, it's so similar to what we're doing with our 3-story garden. It's going to be a pretty easy leap in some respects. On the other hand, when you look at single family, there are so many options out there, right? I mean, how do you focus in one, what product are you actually going to put out? Because you can't just take on the entire single family sector all at once.
Affordable housing probably has more repetitive elements, I'm thinking, than perhaps some higher end or custom housing. Would that be the
Yeah,
segment you'd go after? Or?
We are not focused on luxury housing in anything that we're doing right now. That market actually gets a lot of attention already.
Yeah.
Probably more than it deserves. I've done plenty of that in my days at Miller Hull, and frankly, it gets a little old after time, and you feel like, am I really making a contribution to society by designing these multi-million-dollar homes all the time? So I think we're more interested in providing very, very high-quality architecture for the masses, for real people.
Real people, yeah. So are you using CLT for stairwells and elevator shafts, and what are the design challenges and limitations there?
Yeah, you may have noticed on the Catalyst building in Spokane, that is a CLT shear wall. Those panels are also from Structure Lam, by the way. Another shout out to Structure Lam. Those are 7-layer CLT shear panels. We don't have a product yet certified for that. We will in the future, but definitely in low seismic zones, we plan to go up to 6 stories, maybe a little more, with CLT shear walls. Yeah.
Okay. Mm-hmm. So here's one. How do you square your positive mass timber carbon story with owning concrete factories in India and using steel here in multifamily?
Yeah. Well, the steel, we're really careful about using recycled content steel for sure, right? I mean, every one of these industries has their own sustainability story.
Right.
And I could tell that one. My passion is in mass timber. But if we're going into steel framing for some of our product, we want to make sure that we're using the right, buying it from the right source. And, in India, it just wouldn't make sense to put a CLT plant there. There's just not the natural resource. And this is the way they build, and we don't want to completely change that. What we want to do is we want to be smart about the way we build.
Okay.
We have a team of researchers working on concrete right now. We're calling it K-crete, where we're trying to drive the carbon out of the production of concrete. So we're putting that same kind of R&D emphasis on concrete as we are in other parts of the company. So if, we're not going to make parking garages or go below grade with something other than concrete. So let's figure out how can we be smart about it. Precast is great because you have little waste. The embodied energy is less. It's been proven less than if you're doing all cast in place site cast concrete. So we're just trying to be smart about everything that we do and not be afraid to use any building system. The hybrid approach is really preferred. Whenever it gets us to the finish line, we'll use whatever product we need.
Do you see some forms of hybrid mass timber coming along that might interest you in the future? I mean, right now it's straight CLT with lumber, but obviously there are lots of different solutions that are being experimented with around the world right now.
Yeah, absolutely.
And will your plant be adaptable to those changes?
Well, the CLT plant is really strictly just that. So if we combine it with structural steel, for example, that's a super interesting model. All of our light commercial is based on that. So you see a steel superstructure, and then we're cladding it with CLT panels. We're not purists. We don't have to see all of the walls or all of the structure all out of CLT. We want to use it where it makes sense.
Right. So solution-oriented, basically. Yeah.
Mm-hmm.
Why was Spokane the choice for the CLT factory? Was it workforce considerations, distance to customers, materials, raw material?
Well, we honed in on the Pacific Northwest pretty quickly because of the access to good fiber, especially the East Slope. We're using SPF right now. We'll be introducing Doug fir larch in the near future, but we had access to really good fiber. Eastern slopes of the Cascades. Most of our lamb stock right now is coming from Canada. That's where most of the SPF is. We do know we need domestic sources of lumber, so we'll be moving into Doug fir and larch. Spokane specifically, we looked at a lot of different sites, and we just had so many connections already in Spokane. We had a small office there. We had some of our talent already located there. It wasn't necessarily just a coincidence that that's where the Wolf family all came from as well.
Yeah. Here's a question that's interesting. I was involved also in much smaller scale, but in product development early in my career, and we came up with a new building product called Paralam at that time.
Oh yeah.
And but one of the things that we didn't do is build our plant with wood or Paralam. So the question here is, have you considered using your own CLT light commercial approach to building your factories in Texas and the Northeast?
Oh man, that hits me hard. Yes, I would love to do that. Our plant in Tracy is tilt-up concrete, as you probably saw, because we're leasing the building from Prologis, and right now we're heading down that path in Texas. I've been having some conversations with our head of manufacturing about that.
Right.
I would absolutely love to do that building with our product.
Yeah.
On the bright side, we'll be doing a glue lam factory at some point in Spokane, and we will definitely do that with our light commercial product. That will be a CLT clad building.
Fantastic. Well, there are questions here that could go on for a couple of hours, but I think we probably should wrap it up. Craig, thank you so much for coming here and speaking to us today. We really appreciate it. Thank you.
Yep. Thank you.
That's great. So, yes, Phil, so I'm going to read off some of the questions that we've received here, and it was quite a presentation. It was
sprawling.
What's that?
Sprawling.
You raised a number of compelling potential strategies for improving the value proposition, but how do we get this to happen? I mean, how do we get the ball rolling on this?
Well, I think that there are a bunch of different theories about how this stuff happens. There's the find a good client who wants to try something new theory. But I think the more interesting theory was the one that was put forward by Jeffrey Moore. It was called chasm theory. This is when I first started at Autodesk, the CEO handed me this book about chasm theory. And basically what chasm theory, without getting into a lot of detail, says is the adoption of a disruptive innovation goes through a series of very distinct phases. And there are a bunch of early experimenters, and then there is a period of time while everybody waits to see whether the experimenters are successful, and then the thing goes dead. And if the innovation crosses that chasm, then you get to widespread adoption. But one of the most interesting characteristics of chasm theory is one subset of his demographics of early adopters are people who have a problem that they can't solve any other way. So in my experience, that, for me personally, that happened when I happened to be sitting on an airplane next to the partner from SOM who was running the Freedom Tower project in New York. And we got to talking about his technical problems of trying to resolve 13 stories of below grade trains, pipes, stuff on that World Trade Center site, and whether or not building information modeling was the right strategy. And he couldn't figure out any other way to solve the problem. So he was willing to take the risk of doing that because the problem was otherwise intractable. And then when he was successful, then I really think in the US, that's when BIM crossed the chasm. So you have to identify those customers who have, they're either concerned about the environment or they have concerns about quality or schedule or environmental quality, and they don't see another answer.
Right.
Does that make sense?
Yeah. This is something that I've watched you make presentations online, and one of your presentations was about how you arrived at the idea for BIM. And we have a question here asking that question. Where did this come from?
Well, let's be clear. I showed you slides from 1965, right? None of these ideas are new. You might argue that some of the things that Negroponte was doing across the river in the early 70s were early incarnations of three-dimensional modeling of buildings. That was not a new idea. For me, I got hired, I was a practicing architect, and I got hired by Autodesk to run this business unit. And it was at a moment, it was just one of these times when a bunch of stuff came together. I had come from outside the industry, so I didn't have any baggage about what it meant to actually do software. I also, frankly, didn't realize what a big deal AutoCAD was. And inside the company, it was like a religion, it was like everybody's worshiping at the great cash solution, which was AutoCAD. And I didn't have any of that baggage, so I was free as the strategic leader to think about doing whatever I wanted. And as we began to look at what was going to happen next and what some of the competition was doing and how the technology was starting to emerge, it became clear to me personally that we could not ride this AutoCAD train forever, that drawing wasn't going to be it. There had to be something else going on out there. And and so there were internal projects going on. But when you're in a big company like Autodesk that has large incumbent products like AutoCAD, which is like this like giant celestial object around everything that everything orbits around, you have to do something really dramatic to break away from that. And so a small group of us decided that the really dramatic thing we were going to do was spend $133 million on a tiny little startup that had no customers and the beginnings of some technology that we thought would be disruptive. But I think it was my naivete, frankly, that allowed me to at least think in those kinds of terms. But the theory, to emphasize, we named it. We gave the idea a name. We put the power of a large company behind it. We worked very hard on the technology. We built the argument. We lost tons of money for many, many years. I mean, AutoCAD was the thing that generated the cash that allowed us to do Revit for many years and kind of hang in there.
Right.
But the idea of BIM, the idea of 3D modeling of buildings, that's an idea from the 50s. What was missing was the compute power,
right,
and the graphics resolution.
Right.
So it's all these things. I mean, you never know how these things happen, but convergence of dumb architect who's now business unit leader who doesn't know any better, the desire to do something really, really different, and the compute. The compute was there.
Right.
By the early aughts, the compute was there.
Right. So I'm going to bounce around a little bit here because the questions bounce around. But one factor in the building supply chain is technology adept workers.
Yes.
Do you see the educational institutions providing enough of this skilled labor? If not, how do we get there?
No, definitely not. And I think that at some point there are two sets of questions, right? One has to do with the professional side, and then the other has to do with the construction, fabrication, and labor side. On the professional side, I think we've finally gotten enough people of my generation have retired, and there are enough younger people that I think the architects and the engineers are starting to become more aware of these kinds of questions. I mean, my students are incredibly adept at running a CNC mill. They can program a KUKA robot. We have 60 3D printers in our building. Their laser cutters have become like laser printers. So I think the designers have made pretty good progress on that front. I think the construction labor crisis is going to have to get a little bit worse, and then we'll be forced to make investments in training and changing the infrastructure.
Right.
Because we just won't have the bodies to do the work. I don't
Right.
think it's a training thing. I think it's a resource thing.
Right. Okay.
Does that make sense?
Yes. Being in vertically integrated, being in a vertically integrated company, there is lots of dysfunctional project delivery. There are too many bodies needed in a room, and the meeting format is inefficient to do the everyone in a room solution.
I agree.
How do you visualize execution?
Well, I think there's that question has a philosophical dimension and an executional dimension. The philosophical dimension is about getting a project team aligned very clearly around a set of goals, so you're not arguing over what you're trying to do. You're simply trying to figure out how to do it. Right. That's the philosophical question. Then the executional question, and I saw this a lot in some of the early IPD projects I worked on, is you can have a team that endorses, philosophically and sociologically endorses the idea of IPD, but it's really hard to break out of those old prototypes, those old styles. Up in Providence, Brown University is one of the country's leading institutions around IPD. They don't build buildings that are not IPD anymore. And they still have the same problem on every project, which is it's really hard for the players to delegate executional responsibility to people that they trust to make decisions.
Right.
And it's just as bad on the client side as it is on the contractor side.
Right,
because the president of the university doesn't want to delegate her responsibility to some guy in a room, but that's what you have to do.
Right, right. Here's a question on your favorite topic, wood.
It's going to be a short answer.
Does wood have any advantages to other building materials besides carbon sequestration, such as the design and construction, or as the design and construction process evolves?
Well, I mean, I think Michael Green argues very persuasively that that's the case.
Yeah.
That if you look at the if you look at the structural strategies that are available to designers these days, they're pretty limited. You know, you've got steel, incredibly carbon intensive, expensive and labor intensive, but highly routinized. Concrete, which has terrible problems, environmental problems. And so I think one of the things that Michael's starting to demonstrate is, in the main, wood is a completely legitimate strategy. But the problems of using wood as a construction material are the same as the problems I was describing more broadly in the supply chain, which is things like building codes and convincing the least innovative part of the chain, which are approvals agencies, to be able to use that material in a different way.
Right.
But I think you're going to continue to see that. And I can even see in our pedagogy that wood has a much bigger presence. I mean, Alan taught a studio last semester, co-taught it with Aalto University in Finland.
Right.
And it was two sets of design students working on either side of the Atlantic. And the problem was how to design at large scale with sustainable wood strategies.
Right.
And when I was a student, or even 10 years ago, that was not on the radar screen at all.
Right.
So I think I see it a lot. I'm no expert, but I see a lot of it.
But specifically, what types of value propositions, I mean, obviously totally aside from cheapest solution, but what types of value propositions can you imagine? I mean, are there basically out there for buildings typically?
Well, this idea that I have about inverting the value proposition is to basically say, let's destroy the idea that all transactions in the building industry are based on commodities.
Right.
And let's start making those transactions based on making things happen. So on the left-hand side of my diagram are pretty dumb things about making things happen. Like, we're going to finish this project on time, right? This project's going to meet its budget. We're going to have 0 construction worker injuries. We're not going to pollute the atmosphere. We're going to reduce the waste stream. These are things that are transactional in nature that we can control with our current capabilities. But that pyramid I was showing was a thesis that I write about in my book that says, if the low-level stuff we can get good at and demonstrate, you know, we go to the outcome gym and we demonstrate that we can press more and more weight. You and I couldn't form a collaboration right now and go to a client and say, you know what, we're going to design you a hospital that's going to reduce infection rates by 40%. And by the way, we want to get paid lavishly for that. The clients would look at us and go, how about we just finish one of these things on time for a change? You know, we don't have the credibility. Right. So the thesis here is that a value proposition is really just saying to somebody, I'm going to do X for Y, but instead of Y being, I'm going to hope I get my work done for the scant amount of money you paid me, Y is, I'm going to meet the budget. I'm going to meet the schedule. And then if we can move from left to right on that continuum and build credibility, eventually we'll get to the point where an integrated team can say, this building's going to make people healthier.
Yeah.
This building's going to improve test scores.
Right.
That's what clients really want.
Right. Well, Phil, I want to thank you so much for coming here to speak today. This has been fascinating. And thank you so much once again.
Thank you.
Thanks.